Hello everyone, my name is Yevhenii Symon. I'm technical architect from the customer times. I have around 6 years experience in Salesforce, and during my career I faced with performance issues on huge projects with a lot of customizations. So today I would like to share my knowledge and my findings with you, and I hope they will be useful. So, Lightning Performance Analysis. Let's start. Our agenda for today. And the first item will be Lightning page loading phases. We will discuss the key aspects of the loading of the Lightning pages. It is important in terms of the performance, and it will help us to be on the same page during this talk. Next item will be performance analysis instruments. I will give you the instruments that I used by myself and that can be useful in terms of analysis of the performance of the application itself and even component level. Next item will be Boxcaring. It's the important technical mechanism in Salesforce that definitely has to be taken into account while working on improving the performance of the Lightning pages. Next item will be performance analysis strategy for apps, pages, and even component level. So we will discuss some steps that we can go through to analyze and improve our performance. Then I will share with you my recommendations in terms of building Lightning applications with good performance. And also we will briefly discuss the instruments for measurements that will allow you to consistently measure your performance and to evaluate your performance improvements. So let's go to the first one. Page loading phases. So when user loads the page, first that he sees it's a release animation, right? It's basically time when framework is loading. Next phase is gray or blue screen. It can be like even less than second. It will take less than second, but it can be even dozen of seconds. During this phase, the system gets the information about the page content and the structure of this content, how the components are related to each other, how are they located on the page, and it is done through getTemplateDescriptor call. So the user sees the gray screen until he will get the response for these requests. Also, during this phase, system starts getting the definition of the separate components using Aura component dev, CMP dev requests. So when we got the response from the getTemplateDescriptor, our page will start loading. A few words more about getTemplateDescriptor. Based on our tests, we can assume that frequency and duration of this request depends on the size of the descriptor, basically the size of the response. In the result, it means it depends on the number of content on our page and structure of this content. So the more complicated page you will have, the longer and the more frequent this request will be, and the longer the user will see gray or blue screen. Also, we found out that a user sees gray or blue screen for a longer period of time on his very first loads of the system. So at the start of the day, or if he hasn't used the system for a few hours. So it means that org warm-up scripts can be pretty useful to decrease the influence of getTemplateDescriptor call on our page performance. So in next phase, we are basically user starts seeing the page with the components on it. These components have the spinners because they are just loading, they are making the calls to the server for getting the information that is needed for their load. When they load it, user basically sees a fully loaded page with all the components. But if we look into the network logs, we see that after loading of all the components, Salesforce also does some post-loading requests. That's how I call them. And they don't affect loading time of the page, but they still persist. So here I basically presented the same information, but in more detailed view in a table. So you can look through it in more details if you want. What does affect page performance? We can group these items at least in three columns, right? So first of them is page size, amount of content and complexity of it, which is located on the page. Amount of content loaded at the same moment of time, which is also important. The way how interactions with the server are implemented, quality of backend processes implementation, quality of client-side data processing, the way how components communication is implemented. From the organization side, it's important items is type of the instance, users latency with this organization, workload of the organization with active users and processes. From the client side, important is internet connection, type of the client, it's desktop, tablet, mobile. Also important the browser and even browser version, and hardware. Now let's talk about analysis instruments. First of them is Lightning Usage app. This app mostly can be used for finding the critical weak places in your system where performance degradation can be observed. So this app allows us to monitor what are the pages that are viewed most often in the Lightning experience. It also shows the slowest pages. Also, it allows to track daily and monthly active users, daily and monthly switches to the Salesforce Classic, profiles and users that switch to the Salesforce Classic the most, types of the browsers that are used, and even number of active users. So this one we can use to identify our problems. Next one is the Salesforce Optimizer. It's the Salesforce app that allows you to run the scanner on Sandbox or production, and as a result provides a report with more than 50 metrics that are covering everything from storage, fields, custom code, custom layouts, and much more. And what is important, that this app, instead of providing a report and highlighting the weak areas, it also gives a guidance what admin should do about it to improve and fix it. Next instrument is pretty powerful. It's one of my favorite instruments. It is called Event Monitoring. This instrument is built on the specific events in the Salesforce. The list of these events you can see in the right side. So it's a pretty huge list of events. So Salesforce tracks these events and saves the logs about these events. In terms of performance analysis, probably the most interesting for us will be events related to the Lightning, web clicks, performance, errors. Also interesting is Apex executions, Lightning page view, Apex trigger, and flow execution. The peculiarity of this instrument that events do not appear in the log file until at least 24 hours after they occur. Also, to use this instrument, it is required to have event monitoring license or Salesforce Shield. Few examples. So that's how this instrument can be reached through Heroku app. So here you're able to pick date range to get the logs, type of the event, and interval. Basically, how to group these logs, daily, hourly, for example. And then you will be able to pull the logs, save it, and open. For example, it's the example of the Apex execution log. In the blurred column at the right, you will be able to see the name of the Apex classes with the methods which were used as entry points into the Apex execution. Admin is able to see how many times these controllers and methods were executed, the number of SOQL queries that were done during these executions, and even the time spent for processing these Apex actions. So it is pretty useful, and this information can be analyzed by grouping such logs, by doing a test, and then specific test, downloading the logs, comparing the information from different logs. So it's pretty powerful. And almost the same, you will be able to track from the Aura requests. You will be able to see what are the controllers were called with the methods, and how long these server calls were processed from the client-side components to the server, basically. Yes. So also, upon this instrument, Salesforce allows to do other useful things. For example, feature which is called real-time event monitoring. So you are able to basically subscribe to such events that we just discussed, and do specific actions based on the handling of these events. Also, I found the package on the App Exchange, Eagle Eyes Event Monitoring, which allows you to analyze these logs in prettified way. Personally, I haven't used that, so I can't say whether it is good or not, but you can check it if you want. Also, Salesforce has pretty powerful instrument which is called Analytics Studio. This one probably requires like additional talk about it. It's an application which allows you to analyze, filter, and build the data based on the event logs. So you are able to upload the data sets and build charts which will allow you to analyze it better and faster. So next instrument is not that fundamental in comparison with previous one. It is more about performance of the Lightning pages. It is called Salesforce Community Page Optimizer. It has community page, right, in the name, but it still works in traditional internal Salesforce with the Flexi pages. So it's a Chrome extension which allows to analyze the Flexi pages on load, and also you are able to record the specific session. It has a number of rules and best practices, and it evaluates your page and provides a score against these rules and best practices. So you are able to check whether your page is aligned with best practices. Also, it allows you to track network monitoring, components life cycle, component costs, actions, and their characteristics. I put here a link to this app, and also a link to the guide how to use it. Example: what I meant by actions and their characteristics. So here you will be able to see the list of actions, basically the server calls that were done during your recording session, and their characteristics. Are they background? Are they storable? Are they abortable? And you will be able also to see the time spent for processing these actions. Components. In terms of components and their life cycle, you will be able to see how many times these components were created, how many times they were rendered, how many times they were re-rendered. It's also pretty important and useful for analyzing your components, their performance, and their life cycle, basically. Next instrument is App Builder Page Performance Analysis. So it can be found in Page Builder. So if you click Edit Page, you will see this page analysis at the right bottom corner. So it can show you whether your page performance is poor or moderate, and provides the recommendation to improve the performance. For example, it can show you the components with too complicated structure, or it can show you the information about some instruments that are used that can be a reason of the performance degradation. For example, force refresh view event used with your components. Also, it shows the number of components which are dropped on the page. Lightning Inspector extension. It's also Chrome extension. It also can show you the network, component tree, the requests that were done, but it is also similar to the other extensions. Why I still will use this extension, it's probably for the event log. So you're able to see the events sent during your recording session. It's it's both, like it's standard events and custom events. So it even shows you the application events sent and component events sent. So you can easily analyze whether your component interaction is built in an appropriate way, and also find some problems in terms of performance in case if something was done bad. And the last but not the least, it's our classic network tab in Web Tools. It allows us to see the number of requests. What are the components are sending these requests? Request payloads, timing of the requests, order of requests. So what we can see here? We can see here name of the requests, basically a server calls from the components, in case if we are talking about custom requests, their timing, and also waterfall, the timeline, when they were executed, whether it shows whether the requests were executed in parallel, how long they were executed. So these green lines at the right side, it's basically a timeline. In case if you see aura.apex action execute, it means that it's the execution from the LWC component. In case if it's other dot name of the component and then name of the method, it's a Aura component. You are able to see the name of the component and the payload if you open this row. So you need to click on it, and you will see the payload, the response, all the detailed information. In this tab, you are able to import or export the HAR file. So basically all these logs, it's a big HAR file. It's a big JSON. It means that you are able to build your own analysis instruments by parsing this JSON, and you are limited only by your imagination. So for example, in our case, we built the Python script that immediately shows you the list of Apex methods and Apex classes that were executed during the recording session. And it is useful because you don't need to click on each row to see the name of the class. Also, you're even able to measure the performance, how long some specific components are loaded, because you know what are the components are sending what requests. Also, what else do we see here? You see the numbers in each row, like execute equals 1, execute equals 6 in the row where the arrow is pointed. What does this number mean? For example, 6 here. Let's discuss what is this number. This number it's a number that shows us how many requests are batched into the one request to the server. And this happens because of such mechanism which is called Boxcaring. So what is it and how does it work? Boxcaring is the mechanism of batching multiple queued foreground actions in a single request, XHR, to minimize network traffic. So calls to the server are made as XHR requests. Various browser implementations limit the number of parallel calls to the same host. And in the most modern browsers, it's 6. So at the same moment of time, only 6 parallel requests can be done. Boxcaring effect kicks when all available parallel XHR requests from the browser, XHR connections basically, from browser to the server are busy. Example, we have the page where we have 10 components dropped on this page, and all of them are doing a single request to the server. So on the page load, at the same moment of time, we are doing 10 requests. It means that only 5 requests will be sent to the server as a single request. For when 6 and 7 and other 5 requests, when the system will try to send them, it will see that there is no available connection, no available slot for your XHR requests. So it will batch all these 5 requests into the one request to the server, one XHR. When these requests are batched together, they are coming to the server together, and each action runs in the bundle sequentially instead of in parallel. And it means that if you have 5 requests batched together, which usually take for one request, for example, 1 second to load to get the result from the server, if they are batched together, the response for this batch will be 5 seconds. And it means that all 5 components, instead of waiting only 1 second for the response, will wait 5 seconds for the response, because the response is coming for all these batch requests together. Before Winter 20, Apex limits even applied across all actions batched together in request XHR. Even static Apex variable state was shared between actions in the same request. So let's see in network the example. You see that, you can see on the timeline that at the same moment of time we have 6 requests. Then we need to execute 8 more requests. You can see 8 number at the left side near the error. I also made a bigger piece of this screen for you to see this number 8. So system boxcared 8 requests into the one XHR. And as a result, you can see that system waited for the response for the 9 seconds. And it means that 8 components were waiting for the response for 9 seconds. instead of progressive rendering, when the user sees like one component loaded, the second component loaded, the third component loaded, the user just sees 8 components with the spinners for 9 seconds, which is pretty bad for the user experience in terms of the loading of the page. How this can be avoided? For the Aura components, it can be avoided by using setBackground action. So you simply call the setBackground before enqueuing the action in Aura component, and Salesforce will execute it in the background, and it will never be box-scared. But Salesforce also says that please do not use setBackground for all your actions, because in case if it will be a pretty big list background actions, we can't say that all of them will not be box-scared. For LWC components, we don't have available instruments. What is the alternative for the LWC, custom alternative, that we used, for example, in our projects? We used the approach with the proxy Aura component. Component A is the LWC component. We have a need to call a server. And instead of calling a server using our LWC instruments, we are sending to the proxy Aura component, in our case it's Apex Action Service, the event with class name, method name that needs to be executed, and the payload, and also resolve reject. This Aura component executes the Apex Action Service controller, Apex controller basically. It also with the setBackground function. So it executes it on the background, and it passes class name, method name, and payload. Then this Apex Action Service controller, using a callable interface, call the component A controller with the correct method name and payload. Then component A controller of the component A returns a value, and this value is also returned to the component A through this chain of elements. And as a result, we called the server from the LWC with setBackground. And as a result, this server call is not box-scared. This is the example of the same situation that we saw a few slides before, but now with the setBackground used. So we have here a progressive rendering. You have big number of requests, and they are executed in parallel, executed on background. They are not box-scared, so the user is waiting for 1 second for each component, basically. And the user experience is better, and even the page loading time is better. So recommendations. Use setBackground property for long-running requests. For example, requests which are usually take more than 5 seconds. It helps to get rid of negative box-scaring effects on these requests and also on other requests sent at the same moment of time. For example, you have some component like header component, right? And you usually get response for it during 1 second. And this component is pretty important because it displays the name of the record, and user wants to see it as fast as he can. But the request from this component is box-scared with some other long-running request, which takes more than 5 seconds. And as a result, user will wait for the response for this header component for more than 5 seconds. Another option, other use case when setBackground can be used, it's when we have a component where the information has to be loaded as soon as possible, and we can't wait for a long time. So we don't want for this request to be boxcared. So use set background for it as an option. And also, if you have some specific cases when you have chain of the requests, you can use set background for the requests from this chain, just not to degrade the performance of this chain, not to be in a situation when second request, which is waiting for the response from the first request, is waiting for a long time because first request is boxcared. Let's talk about analysis strategy for overall application performance. First of all, we can identify the most critical use cases using for example, Lightning usage app. Then we can run Salesforce Optimizer also to get weak areas and also guidance what can be done to cover them. We can look into even the monitoring to identify the most frequently used calls that have influence on performance across all applications. Also, then we need to dive deeper into analysis of the pages that have worse loading results and pages that have very similar content in terms of component stack to other pages across an app, and identify the issues like boxcaring, inefficient data collection, inefficient server interactions, bad performance of server processing. In terms of flexi-page, the strategy could be check overall amount of requests sent by component. Identify which requests are sent by which components. Check amount of repeatable requests and their payloads. Determine whether these requests are sent by single component. If repeatable requests are sent by single component, logic and implementation of it has to be reviewed. If similar requests sent from different components at the same time, a dispatcher component or caching has to be considered. Also identify requests that usually takes a lot of time, for example, more than 5 seconds. Execute them in background mode to get rid of negative boxcaring effect on other components. Also identify request dependency by monitoring the order of requests. It allows to identify which components have the chain of requests. Such components need to be additionally analyzed to verify whether this request chain can be replaced by one request or couple of parallel requests. Verify that requests are needed to be sent. Payload of requests in some cases depends on dynamic configuration. Make sure that requests are sent at all, not sent at all, instead of sending it with empty payload just because there is no configuration for some specific part of component's logic. And important one, all of them are important, but this one is critical, I think, and it should be considered as the first one. Discuss whether part of the page content can be moved to the separate Salesforce tabs and accordions and simply moved out from the loading context, basically to decrease the amount of the content which is loaded at the same moment of time. Analysis strategy for the component level. We need to analyze components' behavior isolated and on the flexi page where it is used to identify performance degradation by what basically performance degradation is caused, whether by other components and boxcaring effect or performance of these components is bad just because of it. Next point is analyze component lifecycle, how it renders through renders. Analyze how this component communicates with other components. Check whether there is no redundant listeners. Check dependency between components. Verify the efficiency of server interactions. Try to minimize number of requests to the server from the component, not except some specific cases when we need to send more than one, but better to have less. Analyze effectiveness of the server processing. In terms of recommendations, always try to keep your pages clean, trying to decrease number of components on it. Try to move components into tabs accordion to load them only on demand. Try to decrease amount of server interactions whenever it is possible. Try to remove dependency between requests to send them in parallel. Keep an eye on request payload. Don't send requests if there is no need for it. Move long-running requests to the background to get rid of negative influence on other requests and components. Load configurations for the components that are displayed on demand only when user is opening these components. Think about using caching through storable actions, platform cache, client-side cache, but need to take to the account caching validation issues. Verify alignment with the best practices, keep API version up to date, enable secure browser caching, and enable CDN. Also, in terms of configuration of the standard components, we still need to try to decrease number of components on the page. We need to use tabs and accordions. Also, we need to decrease number of fields in record detail component. Less than 60 recommended for desktop and less than 25 for mobile. Also decrease number of related lists displayed, especially heavy loaded. Hide news or Twitter component. And for the pages that are used on phone device, it is recommended to have less than 8 visible components on the page. Also, while doing the performance improvements, we need to somehow understand whether we improved something or not, right? So we need to do measurements. First of all, before the measurements, and to have a clear vision whether your measurement is valid, you need to compare the state of your instance and your internet connection. This can be done by opening a speed test. So just append speed test to your domain to start speed test. Here we have several metrics. From my personal opinion, probably octane score and latency are the most important. Salesforce has his own recommendations. What is the octane score should be, what is the latency should be, so you can check them out. And briefly about the instruments that can be used for the measurements. Salesforce is a pretty complicated platform in terms of performance and measurements. It is hard to do a clear, pure measurements because a lot of system-specific processes are also launched and executed. But we have a list of the instruments, and you can use them based on your purpose, on your demand. So first of all, event monitoring, right? We have plenty of data there. You can see the time of loading of the flexi pages there. You can use it to check the time of loading of the flexi pages, for example. You can compare it before the performance improvements and after. Also, you can use EPT counter for the page loads. Salesforce recommends this instrument. So you simply add EPT visible to your URL. And then on the page loads, you will see the counter at the right side, top right side, and it will show you how long this page was loading. Next instrument is just a stop and watch method, right? Simple one. Just on your timer, you can start timer when you loaded the page, start loading your page, and when it is loaded, just stop it. But it's pretty simple, but probably not that effective in terms of automations and big number of measurements. Scripts based on the network info, hard files. That's what I told you about the web tools and network tab. We are able to download hard files there, parse it, and see the metrics. And as a result, it can be easily automated. Also, component-specific scripts that track component lifecycle. So we can check, like start the timer when a component is inserted into the DOM, basically, and stop the timer when, for example, spinner is hidden. Just an option for automation, automated measurements for the component loading time. And other automated tools. There are some existing tools for the measurements. They are not ideal to, and you are able to implement your own tools based on the network info, based on the DOM elements. So here you're also limited only by your imagination and skills. So that's all regarding the performance and performance analysis that I would like to present for you today. So thanks for your attention.